Start with. Good afternoon, everyone. I am Shalu. I have done my research under the guidance of Mridula Renu Sinha ma'am. She is an associate. She was an associate professor in Magadh Mahila College. The topic for my presentation is monitoring and assessment of urban wetlands for pollutant removal. नहीं है। अच्छा अच्छा मैं स्टार्ट करूँ यहाँ से ओके
No, you just start.
Okay, so,
and some objectives of your research.
So I should skip the introduction part then. No need of introduction. Okay,
To have an introduction.
sir. Okay, sir. Direct to objective.
Direct to objectives. Yes.
My research objective. My research objective for my work is to identify natural wetlands in the study area and to identify the reason for diminishing of wetlands, evaluate the impacts of pollutant on urban wetlands, and also to identify the drivers that affect the water body, provide practical wetland restoration approaches for maintaining the health of the natural wetlands. The scope of research. Identify the main drivers of pollution load to provide the scenario of wetlands with respect to water quality, recommendations for wetland rejuvenation. Study area chosen. Patna, an ancient city, once had numerous urban wetlands. Many of these wetlands have been lost due to anthropogenic activities and encroachments. 2 wetland sites were selected for the study using Google Maps and local consultation to represent varied pollution sources and environmental conditions. The first site was Sandalpur Pond, situated near the well-known Sandalpur Shani Mandir temple of the area, surrounded by busy streets in a densely populated urban setting known for its unique physical characteristic, currently used as a dumping site by the local population. Second one is Anishabad Pond. It's located in the Anishabad area. This is also surrounded by densely populated residential area. This is commonly used by local residents for bathing and washing clothes. Overview of monitoring and assessment of approaches. The water quality parameters that I have done for this research was the physical parameters. The parameters I have taken was temperature, pH, electrical conductivity, and turbidity. Chemical parameters was phosphate, nitrate, DO, COD, BOD, total solid, total dissolved solids, and total suspended solids. Microbiological indicators, total coliform and fecal coliform. Heavy metal analysis of metals such as copper, zinc, lead, and iron. I have also done socio-environmental assessment by questionnaire survey conducted by the local community perceptions on cause of wetland degradation, local community perception on impact of wetland on associated neighborhood. Water quality monitoring techniques. Water samples were collected from 6 equidistant points, stations and 2 sites during summer and winter of 2022 and 23 using pre-cleaned borosilicate and propylene bottles. For physiochemical analysis, water samples were collected in a pre-cleaned distilled water rinsed bottles. Dissolved oxygen samples were collected in 300 ml BOD bottles and fixed on site using manganese sulfate and alkali iodide reagents by Winkler methods. Separate water samples for biochemical oxygen demand analysis were collected in 300 ml BOD bottles without any chemical addition, transported to the laboratory. Microbiological samples, total and fecal coliforms, were collected in sterilized 500 ml borosilicate bottles wrapped in aluminum foil and transported in an ice box to the lab within 24 hours. For trace metal analysis, sample was preserved with 5 ml of pure nitric acid in polypropylene containers and reduced to 25 ml via steam bath evaporation. These are the methods for testing water quality. I have tested water quality parameters were examined using the standard methods AFA 2070. Here is a quick rundown to the lab technique used to measure these variables. like a temperature thermometer, pH meter, electrical conductivity. Okay, sir. These are methods of testing water quality. Data analysis, physiochemical characteristics analyzed using mean values and standard deviation. Statistical analysis conducted to evaluate ecological impact on urban wetlands. Student t-test applied to identify significance difference. Statistical tool, SPSS version 16, Microsoft Excel 2008. Water quality index. The arithmetic water quality index method aggregates multiple water quality parameters into a single number representing overall water quality. It simplifies complex water quality data into a score that reflects whether water is suitable for human consumption or not. Parameters used. Common parameters include pH, DO, BOD, nitrate, phosphate, turbidity, and TDS. Quality rating scale QI for each parameter. Quality rating is calculated as QI is equals to VI minus V0 divided by SI minus V0 into 100, where VI is measured, where VI is a measured value. SI is the standard permissible value from guidelines such as BIS or WHO, and VO is the ideal value for that parameter. Each parameter is assigned a unit weight inversely proportional to its standard value. Here, SI is again the standard permissible value of the ith parameter, and K is proportionally constant chosen so that the sum of all weights equal 1. To determine K, the formula used is K equals to 1 oblique summation bracket 1 by SI. In the final step, the water quality index WQI is calculated by the given formula. The resulting WQI values provide a single number that represent the overall quality of the water sample. These are the interpretations of WPI, for which the WQI value ranges 0 to 25. Its water quality status is excellent, that is suitable for drinking. 26 to 50, it's good. It's acceptable for domestic use. 51 to 75, it's of poor quality, suitable for irrigation only. 76 to 100, it's of very poor quality, it's unfit for drinking. And if it is more than 100, it's unsuitable for any users. That's need treatment before use. Questionnaire survey was conducted with 120 respondents at selected locations. Local communities have heightened awareness of environmental and resource changes. Their insights are valuable for understanding perceived impact and changes. Face-to-face interview was conducted and responses recorded using standardized data collection template. Participants were fully informed about the study purpose, clarification provided for any concern regarding the interview process, evaluation of perception, public perception of urban wetland degradation, assessed using 5 broad categories of drivers. Importance ranked under using a 3-point scale. One is highly important, that's given a 3. Moderately important, that's given 2, and LI, that is least importance, that's given 1. Assessment of impacts, both positive and negative impacts of urban wetlands on neighborhood captured. Response recorded using yes or no option in the questionnaire. Analytical methods was done. In this, in order to meet the aims and exact relevant conclusion, the data for reason behind diminishing of wetlands were examined utilizing descriptive statistic, frequency, percentage, average, and rank order. Following the scoring methods, numeral codes were assigned and the results were calculated at WMS, that is weighted mean score. For the calculation of WMS for each driver, the frequency was calculated and subsequently the score associated with that frequency was multiplied. The resultant value was summed and the final value was divided by the total number of respondents. This is the formula where HI is highly important, MI is moderately important, and LI is least important. These are the questions. Now coming to the result. First, I have done the physico-chemical analysis. First, starting with the temperature. Now, as you can see from the graph, what we can conclude is it's obvious the summer has a higher temperature than winter. The same result has been interpreted in this. And coming to the t-test, which shows significant, all the values were significant for both the seasons. For temperature annual variation, we can see from the annual variation that the temperature has increased in 2023 than in 2022 for both the years. And it was not statistically significant. pH. The pH generally hovers between 7.8 to 8. 8.1. Yeah, 8. And here also the summer shows the high pH than winter for both the sides. And the t-test it signifies that it was not significant for both the season of all the sites, for both the site also. Now, annual variation, what does it show? It shows that the pH is decreasing, has decreased from 2022 to 2023 for both the years. So for both the sites, and it's also statistically significant by the t-test. Turbidity. What we can conclude from the turbidity result is that the summer shows a higher turbidity for both the sites, and it's also significant for all the for both the sites for both the years. And in annual variation, what we can see is for 2022, we can see for site 1, we can see that 2022, the turbidity was higher than 2023. And for site 2, the turbidity was higher in 2023 than in 2022, but they were not significant. Electrical conductivity. What we can see from the electrical conductivity also, the summer value were higher, and it was only significant for the site 1. It was only significant for the site 1, or when compared with the summer and the winter. And annual variation as seen from the graph, we can conclude that for site 1, 2022 and 2023, both had almost similar values, but at site 2, the value for 2022 was greater than 2023, and the t-test also showed that they were not significant. DO was higher in winter than in summer, and it was not significant according to the t-test for both the sites for season compared. Sorry, it was significant for it was significant for site 2, summer and winter 2023. That's the values recorded was 0.026. Annual variation in DO at both sites during the year 2023. What does it shows that at site 1, the value was almost similar for site 1, and for site 2, from the graph as shown, it was decreasing, and it was not significant also from the t-test. BOD. The BOD value was higher for summer than in winter for both the sites, and it was statistically significant for only site 1 when compared summer and winter of 2023. That is the value showing 0.026. Annual variation in biological oxygen demanded during year 2022 and 2023. What we can see that 2022 shows higher BOD than 2023 for both the sites, and it was not statistically significant also. Chemical oxygen demand. So chemical oxygen demand shows a higher value of summer than in winter, and coming to the statistically significant, site 1 only shows statistical significance of summer and winter 2023. That is the value recorded was 0.016, and annual variation we can see that at site 1, 2022 COD was higher than 2023, and for site 2, COD was higher in 2023 than in 2022, and it was not statistically significant according to the t-test. Nitrate. Coming to the nitrate also summer recorded a higher value, and according to the t-test, what we can conclude from this, that site 1 for the season compared summer and winter 2022, it was statistically significant, in fact highly significant, and the same site 1 for 2023, it was also statistically significant. And annual variation, what the nitrate shows is that for 2023 for both the sites shows a higher nitrate value than 2022, and it was statistically significant also. Phosphate. Seasonal variation in phosphate shows almost that summer has had a higher value, and coming to the t-test, which shows statistical significance, I can conclude from this that site 2 had recorded 0.0001 value for both the years, and it was highly significant. For annual variation in phosphate, we can see that for site 1, 2022 2023 had a higher value than 2022, and for site 2, 2022 had a higher value than 2023, and statistical significance was shown by site 2. Total solids. Total solids was higher for site, it was also higher for summer value. It's also higher in summer only. From the T test, we can conclude that it was statistically significant for the site 2 summer and winter 2022 and site 1 summer and winter 2023. Annual variation, what we can see, at site 1 2022 had a higher value than 2023, and same for site 2 also, and it was highly significant also. Total dissolved solids. Site 1 shows a high value of total dissolved solids than site 2. We can see from the graph, and what we can see from this is it's highly significant for only site 2, that is 0.002, and annual variation in total dissolved solid. We can see that at site 1, both the values are almost same, and for site 2, 2022 shows a higher value than 2023, and the t-test shows the statistical significance. Total suspended solid. Total suspended solids, site 2 shows a higher value of total suspended solid, and that too in summer only. And from the t-test, we can conclude that it is highly significant for site 2 and site 1 for summer 2022 and summer 2023. Now, annual variation in total suspended solid. What we can see is site 1 has a higher value in 2022 than 2023, and site 2 has a higher value in 2022 than in 2023. And coming to the t-test, it shows that site 1 only shows statistical significance. Total coliform. Total coliform was higher in summer than in winter, and its value shows significance for site 2, site 1, site 2 of summer 2022, summer and winter 2022, summer and winter 2023, and summer and winter 2023. Annual variations shows that total coliform trend has decreased from 2022 to 2023, and at site 2 it has increased from 2022 to 2023, and it's statistically significant. Fecal coliform. Fecal coliform value was also higher in summer than in winter, and the t-test revealed that it was statistically significant for site 2 and site 1 and site 2 for summer and winter 2023, and summer and winter site 2 also for summer and winter 2023. Annual variation of fecal coliform, what it shows is site 1 had a higher value in 2022 than in 2023, and at site 2 it has also this 2022 value was lower than in 2023, and it's also highly significant. Coming to the heavy metals, what we can see here is that site 1 has shown a higher copper value than site 2, and it was not significant for any of the sites according to the t-test. Annual variation in copper was shows a upward trend from at site 1 from 2022 to 2023, and at site 2 it was almost same, and it is highly significant from the t-test concluded. Lead was also found higher in site 1 than at site 2, and it was not statistically significant for any of the sites when we compare both the years, summer and winter 2022 and 2023. And annual variation in lead, what we can see from this is site 1 had a lower value in 2022 than in 2023, and site 2 has a higher value in 2022 than in 2023, and it's also statistically significant. Zinc also shows a higher value for site 1 only than site 2, and it was also not statistically significant for any of the sites for any of the season compare summer and winter. And when we come to annual trend, we can see from this is that at site 1 we can see that the value was higher in 2022 than in 2023, and the same for site 2 also, which is highly significant also. Iron. Iron was higher for site 2 than for site 1, and none of the result was statistically significant. And coming to the annual variation of iron, what we can see is at site 1 also 2022 had a higher value than 2023, and same for site 2, what we can see is 2023 had a higher value than 2022, and it's statistically significant also. These are the table for the water quality index. The value came 152.56 for the water quality index of site 1 for the year 2022, and water quality index for the year site 2 for the year 2022 was 157.44, and for water quality index of the site 1 for the year 2023 it was 127.92. And what जी मैम अच्छा स्लाइड चेंज नहीं हुआ, ये तो बढ़ा चुके थे. इंटरनेट स्लो. Hotspot. WPI for water quality index of site 2 for the year 2023 was 180.35. This is the graph for water quality index of site 1 for the year compare when we compare that site 1 had a higher value in 2022 than 2023, and water quality index for site 2 was lower in 2022 than in 2023. Questionnaire survey personal information of respondents. I have selected male and female. This is the graph for male and female, and their age was 18 to 30, 31 to 45, and 45 to 46 to 65, and their level of education was intermediate, graduate, and postgraduate. I have taken 5 drivers for wetland degradation. First is the urbanization, then pollution, then climate change, lack of awareness and education, environmental laws, limitation, and enforcement gaps. This has been calculated by the method given. What we can conclude from this, that urbanization was at rank 1, pollution was at rank 2, climate change was at rank 3rd, lack of awareness and education was at rank 5th, and enforcement law limitation and enforcement gaps was 4th. This is the distribution of all the responded distribution to the realization of the drivers of wetland degradation. This is the pie chart for reason for diminishing of wetland. Now, impact of wetland on neighborhood. They have the positive impact. What we can see is groundwater recharge, flood control, temperature regulation. Negative impact, mosquito breeding ground, unpleasant odor, decreased property value, animal menace, source of water pollution, seasonal accessibility, maintenance cost. Discussion and conclusion. Seasonal variation was evident, with summer showing higher values for most physiochemical parameters due to increased temperature, evaporation, and reduced water flow. pH remained within permissible limit across seasons, showing minor fluctuation. Nutrients increase in summer, attributed to enhanced microbial activity, runoff, and organic pollutant accumulation. BOD, COD, and turbidity exceeded BIS limits, particularly in summer, indicated severe organic pollution from untreated sewage and anthropogenic activities. TS, TDS, and TSS were elevated during summer. TDS exceeded BIS limit at site 1, suggesting contamination for erosion, reduced dilution, and human activities. Microbiological analysis revealed high total and fecal coliform count at both sites throughout the study period, exceeding BIS standards due to sewage contamination, open defecation, animal excess, and surface runoff. Higher bacterial loads in summer were linked to increased temperature and organic inputs, while winter showed reduced microbial activity due to lower temperature. Heavy metals, lead, copper, zinc, and iron exhibited seasonal fluctuation with higher summer concentration caused by reduced dilution, higher evaporation, and increased bioaccumulation. Vehicular emission, urban runoff, and atmospheric depositions were identified as major metal sources. Although winter showed slight dilution effects, metal concentration exceeded permissible limits year-round, indicated persistent anthropogenic pressure. WPOI values at both sites consistently classified as the water as unsuitable for any use, indicating persistent and severe pollution posing serious public health risk and demanding immediate remedial action. The findings underscore the need for continuous monitoring, effective pollution control measures, and improved water management strategies to restore and safeguard water quality. Questionnaire survey results identified urbanization and pollution as the most critical threats to wetlands, while climate change and governance issues were recognized as secondary concerns. Education and awareness gaps, though less urgent, remain relevant. The study highlights the importance of integrated wetland management, emphasizing environmental protection, sustainable urban planning, policy enforcement, and public participation. Urban wetlands provide significant benefits such as flood regulation, groundwater recharge, recreational space, aesthetic value, and mental well-being. However, poorly managed wetland pose challenges includes mosquito proliferation, waterborne disease, waste dumping, foul odors, and environmental degradation. Overall, urban wetlands are vital to urban ecosystem, but their sustainable integration requires careful planning, active community involvement, and consistent maintenance. These are the recommendations for rejuvenating of wetland. We can rejuvenate the wetland through constructed wetlands to naturally filter inflow using plants and microbial process, sediment dredging to remove nutrients at meta-rich deposit, filtration system, sand, gravel, biochar to enhance pollutant removal, by phytoremediation with wetland plants like Typha, Phragmites, Scribus, Eichhornia, restoring natural water flow to allow wetland to self-generate, controlling invasive species, to protect native flora and fauna, replanting native vegetation for soil stabilization and biodiversity support, creating microtopography, cool ridges, hummocks to diversify habitats, managing water level and sediment with adjustable weirs and targeted intervention, enhancing stormwater and wastewater management via green infrastructure and localized treatment, preventing dumping and enforcing regulation to reduce contamination, regular monitoring and promoting zero waste practices, community involvement and awareness program to ensure long-term protection, integrating wetlands into urban planning and strengthening legal protection. Restoring urban wetland improves water quality, flood control, carbon capture, biodiversity, and urban resilience. Future scope of work. Long-term monitoring programs, extending the study beyond 2 years to capture long-term pollution trends and assess the impact of climate variability and urban expansion. Inclusion of emerging pollutants, investigating the presence of emerging contaminants such as pharmaceutical, personal care products, microplastics, and endocrine disruptors. Biodiversity and ecosystem health assessment integrate floral and faunal biodiversity service to link pollution levels with ecological impacts and wetland health indicators. Integration with urban planning and GIS. Use GIS and remote sensing tools to map pollution sources, land use patterns, and wetland catchment areas to inform planning and zoning. These are the publications. Conference I have attended. Certificates. Other references. Sir, acknowledgement पढ़ना है या फिर skip करना? Then thank you, sir.
Now, what Shalu did in her research presented nicely, but before I request Professor Raghunathan to ask for clarification of queries or questions. I would like to have some questions from the second exam. Second examiner is Professor S. Ramakrishna, Department of Zoology, Bangalore University. So, few questions he has raised to be asked during the Viva-Voce. What indicators would you consider most reliable for assessing the ecological health of an urban wetland, and why?
Sir, the most reliable parameters which for assessing the ecological health of urban wetlands, what I can consider is dissolved oxygen, BOD, microbial contamination, because as they increases, that contaminates the water quality.
Second is, how does the vegetation type influence the self-purification capacity of wetlands?
So vegetation type influences the self-purification capacity of wetland. As whatever vegetation is present, their roots trap the soil particles. They help to settle the metals down there, and they increases the nutrients, and they also reduces the water flow, so that the pollutant level remain less in that particular wetland.
Actually, there is one plant, sir is wanted to know that there is one plant
Yeah.
which are important vegetation of the wetland which absorbs heavy.
So
Remove
Okay.
heavy
They remove heavy metals by absorbing.
So Typha latifolia, that is the plant, I think so.
Iconia.
Sorry, Iconia, yeah, Iconia, sir. Yeah, Jalkumbi. Yeah.
There is what challenges are typically encountered in monitoring the water quality in urban waterlands, and how can they be addressed?
So, according to me, what I faced in monitoring urban wetlands was, sir, the access. It was very hard for me to get through or to collect the water sample. That was the main problem, and the seasonal variation. You can't conclude what would be the next result for that when we compare summer and winter, and the anthropogenic pressure, day by day dumping. That is also the cause.
Another is how does the presence of heavy metals in wetlands interact with the microbial communities?
Heavy metal interact with the microbial communities.
Any idea you have?
So microbial communities, they survive there with predation and competition.
How the microbial communities interact with the heavy metals in the wetlands?
So I don't know this answer. Sorry.
Last is your study reports the elevated BOD and COD in the summer exceeding the permissible limits.
Yes.
How these results relate to anthropogenic activities and natural processes in urban wetlands?
So this relates as the temperature increases, there's more.
Anthropogenic activities.
So once you can repeat.
How the increase in BOD and COD in the wetlands during the summer
Yeah.
is related to anthropogenic activities.
So BOD, that means that more waste dumping is done at the site.
During the summer?
No.
Not in the winter?
No.
How? You have reported elevated BOD and COD in the summer.
Yeah.
So how these results relate to anthropogenic activities and natural processes in the urban wetlands?
How to correlate the anthropogenic pressure with increase of these two parameters only in the summer season?
So as the temperature increases,
Or
microbial.
you can correlate with the natural processes.
Yeah, natural processes of the wetland. That is, as the temperature increases, microbial activities also increases. Then there will be more degradation of the organic compounds right there. That I can relate this like this only.
And with respect to the anthropogenic activities,
So anthropogenic activities is what? Like we are dumping solid waste.
related to anthropogenic.
Yeah, it's related. It's related. Yeah.
मैंने क्या करेंगे गर्मी के दिनों में
सब मैम समर पे इसलिए ज्यादा होते हैं क्योंकि टेम्परेचर हाँ सर
ज़्यादा नहीं होगा।
सर दोनों सीजन में तो मैंने चेक किया दोनों में जो वाटर को
माने anthropogenic activities से कोई correlation है?
सर है सर वो कोरिलेशन
समर में जो elevate हो रहा है।
हाँ एलिवेट हो रहे क्योंकि सर टेम्परेचर को तो मैं नहीं बोल सकती सीवेज डंपिंग वगैरह हो रहे हैं वहां पे
Serious dumping during the summer ही होगा।
सर होता है लेकिन माइक्रोबियल एक्टिविटी जो होता है सर वो समर में ज्यादा इंक्रीज करता है तो डिग्रेडेशन ज्यादा होता है, कंजम्पशन वो ज्यादा डिग्रेड करते हैं वो
तो
कंटामिनेंट्स
हम
को।
लोग ये मान कर चले तुम्हारे खाने के हिसाब से कि एंथ्रोजेनिक प्रेशर जो है वो इंटेंसिफिकेशन ऑफ द माइक्रोबियल एक्टिविटीज के टर्म्स में तुम कहना चाहिए।
या
In terms of the intensification of the microbial activity.
यस सर।
Otherwise, anthropogenic activities की कोई direct relation नहीं है.
नो।
Now I request Professor Raghunathan to ask a few questions.
Sir, it was a nice presentation, but almost both the other second examiner and the other the questions are similar. She has explained in a detail. She has presented very good. Anyway, just for clarification and other participants to know, I would like to know what are the main sources of pollutants entering urban wetlands in Patna.
So main sources of pollutant entering urban wetland in Patna are main is the solid waste dumping, sewage. They directly put the sewage in the wetland. They have created a channel. The society where I have studied my I have done my Ph.D. work on. They have created a channel that holds the sewage activities. The sewage water. They directly dump out there. These are the factors.
Okay, how do the heavy metals in the wetlands interact with the microbial communities?
Same answer.
Okay. Anyway, as you said, you were explaining now how climate change could further influence pollutant dynamics. It is during the when the temperature is high. Tell me.
Sir, if rainfall increases or if temperature increases down the year 10th year or 20 year, what we can say, if the rainfall increases, we have more runoff. That increases the pollutant, and if the temperature increases, we have the DO will be less. That affect the urban wetland.
Okay, other questions are almost similar to the. I have few more questions, but it is similar to the earlier asked questions. Anyway, now, sir, Professor HOD, is it open for other audience to ask the questions?
Yes, sir.
If anybody is interested, they can ask the question.
All present here to ask.
Yeah, it is open for discussion.
So faculty members and the research scholars also ask the questions if they have.
Ma'am, one is located in Anishabad and the other is located in Sandalpur. Yeah, Sandalpur area. Ma'am, काफी distance है. काफी distance है.
What would be the reason, the differences which you get?
Yeah, ma'am, differences is that the anthropogenic pressure, what the present wetland in that area is facing from the communities residing there.
Whatever parameters.
Yeah.
What would be the reason, the difference between the two?
What the parameters of the pollution sources may be different, ma'am.
Maybe different what you have observed.
I have observed, like at site 2, what I saw that people were using that for washing clothes and they were taking bath there. At site 1, there was no washing and bathing there done. Source of heavy metal, ma'am. या मैम साइट 1 पे जो हेवी मेटल ज्यादा आया है मैम, वहां पे मैंने देखा कि गैरेज वगैरह है फॉर ये गैरेज बनाते जो, तो उसमें लेड वेट ज्यादा आएगा ही क्योंकि एकदम पास में है मैम, तो वो ड्रेन करके वो रन ऑफ से वो जाएगा ही जाएगा वहां पे, और वो रोड पे है तो वेहिकुलर पोल्यूशन मैम पाइप वाइप रहेगा, वो सॉरी टायर वायर रहेगा तो उसका कुछ तो जाएगा उधर, तो मैम इसलिए लेड ज्यादा आया है वहां पे साइट 1 पे। और बाकी मैम वेहिकुलर पॉल्यूशन क्योंकि वो रोड पे ही है। नहीं मैम सर साइट 1 आपको यहाँ संदरपुर है सर, शनिचरा मंदिर के पास है। No ma'am, site 1 has higher pollution level than site 2 for in terms of what we can say heavy metal, what ma'am was asking. साइट 2 में ज्यादा था आयरन मैम जी, क्योंकि वहाँ मैम मुझे क्या लग रहा है कि वहाँ पे आइडल इमर्शन भी लोग करते हैं साइट 2 पे, आइडल इमर्शन भी करते हैं वहाँ पे, घर से ले आके पूजा पाठ का सामान कुछ डालता देखा है मैंने उसमें डालते हुए। मे बी दैट वुड बी द रीजन कि घर से कुछ भी वो लाकर, हाँ वो हमेशा करते हैं सर, जब भी मैंने लिया तो मैंने देखा है कि घर का जितना पूजा पाठ का सामान आता है उसी में यस सर, वो तो मर्क्यूरी रहेगा सही में। नहीं नहीं
और
सर।
साइड 1 पे जो तुम्हारा हेवी मेटल का इन्फेस्टेशन है
जी
संदलपुर और वो इलाका सहीराम होगा, उसमें बहुत इंपॉर्टेंट बात है तुमने। और बैटरी लीकेज सबसे ज्यादा।
हाँ सर, बैटरी लीचिंग है वहाँ पे। हाँ वहाँ पे है,
बैटरी है वहाँ आता है।
वो पास में बहुत सारे शॉप्स है। हाँ देखा है मैंने सर। जी ओके ओके।
So any more question?
Sir, if there are no questions, we can conclude. We can conclude the session.
But your blessings are required, sir.
Sir, definitely. Now I'll come to the remarks.
Yeah.
Most respected head of the department and Professor Dean Sciences and guide Dr. Mridula Renu Sinha and my beloved most respected Professor Dr. Shio Satyaprakash and all the audience present there and the staff members of Patna University and my dear colleagues and friends, research scholars who are all attending the Viva-Voce. I have thoroughly gone through the thesis. The candidate has worked extensively and has presented our research findings in a very good, excellent manner. Because I am the one of the examiners of the thesis evaluation also. And thanks to the university authorities for giving me a chance to both evaluate and to be an external examiner for the Viva-Voce examination also. Hope the floor will accept that the candidate has presented the thesis very well and also she has defended the thesis very well.
Thank you sir.
Hope you all agree, in the audience will agree to my comments. She has defended the thesis, she has presented the thesis and also defended very well. So anyway, with these remarks, based on the reports and also based on the presentation and the defense, I recommend her, Miss Shalu hereafter henceforth can be called as Dr. Shalu. This is
Thank
my
you, sir.
recommendation to the University of Patna University. Thank you. Thanks for the opportunity given to me. My best congratulations to the guide and also to the student. Thank you.
Thank you sir. Thank you. Thank you sir.
Thank you, Professor Raghunath. We are meeting again after a month.
Yes, sir. Yes, sir. Yes, sir.
We are recommended for the second exam. After a month, we are holding the session
It will be
again.
better if you start by 12 o'clock or 11:30. It will be better.
Yeah.
All right. Okay. Thank you.
Thank you sir. Thank you sir.
again.
Thank you.
सर क्या देख लेंगे सामने?